In this video, we're going to talk about the area of composite figures. And a composite figure is a figure that is made up of two or more shapes. So what we're doing is we're creating these figures that are composed of some of our more basic shapes that we are aware of. So for example, we have on the screen here, we've got a parallelogram and a rectangle that combine to form this odd looking shape here, and a square and a semicircle that form this shape, and a trapezoid and a triangle make up this odd shaped quadrilateral. So finding the areas of these objects can be a little bit difficult, but if we break it down into the basic shapes that compose it, then we can find the areas of them actually quite easily. So how do we do that? To find the area of a composite figure, what we need to do is break the figure into basic shapes. Now, there's not just one right way to do this. There are some figures where there are multiple ways to break the figure down into basic shapes. So really, it's kind of up to your imagination how you can break it apart. Just be careful with figuring out the measurements after you've broken it apart. And then we're going to find the area of each basic shape, and then we're going to add all the areas together. So we want to break down our composite shapes into triangles, circles, parallelograms, rectangles, trapezoids, and so on. So how do you find the area of these basic shapes? Just a reminder, here are some basic shapes that you should always know how to find the areas of. Now, the parallelogram is a very, very basic shape, and the area of that is base times height, with the base being here and the height being perpendicular to it. And of course, the triangle is 1/2 of a parallelogram, so the formula is 1/2 base times height. Again, base and height are perpendicular. They are always perpendicular. Now, the trapezoid might be something that is easily forgotten and very rarely remembered. Remember, a trapezoid is a quadrilateral with only one pair of parallel sides. And those parallel sides are called the bases. So there's base 1 and there's base 2. To find the area of a trapezoid, we need to take 1/2 of the height times base 1 plus base 2. So we're going to add the two bases together, and then we're going to multiply that by the height and then take 1/2 of that. Now, there are proofs for why that works, but I'm not going to get into that in this video. And then, just like we learned in the last video, we have our circle, which is pi r squared. Once again, even though pi r round. So let's find the area of some composite shapes. So here we see this arrow looking shape, and we want to find its total area. So what we're going to do is we're going to break it into its component shapes. And most of us see kind of immediately that there's a triangle here on the end and a rectangle attached to it. So we're going to break this composite figure into those two basic shapes, the triangle and the rectangle. So to find the area of a triangle, we're going to do 1/2 base times height, and the base here, we're not given the length of the base, but we can figure it out. Each side that kind of hangs over the edge here is 6 inches, and this section right in here is 15 inches. So that is a total of 27 inches, or 15 plus 12. So the base of our triangle is 27 inches. So that's 1/2 times 27. And then the height of the triangle is this perpendicular distance right here to the vertex, and that is 8. So 1/2 times 27 times 8 gives us an area for the triangle of 108 square inches. And then I'm going to find the area of the rectangle separately. And again, our area of a rectangle is base times height, and that would be 23 inches times 15. Gives us a total area of 345 square inches. And then I'm just going to add those together for a total area of 453 square inches in our arrow looking shape. So that's really the basic idea behind composite shapes, is breaking it down into shapes that we know how to find the areas of and then adding them all together. So here we have the teardrop or ice cream cone, or whatever you want to call it, looking shape. And this is composed or comprised of 1/2 of a circle, which we call a semicircle, and a triangle. So we're going to find the area of these two shapes separately. And a semicircle, since it is half of a circle, it's going to be 1/2 pi r squared. And the radius of this circle, well, the base of this triangle is 6 millimeters, so halfway across the base would be 3 millimeters. So our radius is 3 millimeters. So 1/2 pi times 3 squared, or 1/2 9 times pi, or 4.5 pi. And if we calculate that and round that to the nearest tenth, we get an area of 14.1 square millimeters. Then our triangle is 1/2 base times height. And the base is 6 millimeters and the height is 16 millimeters. So 1/2 times 6 times 16 is 48 square millimeters. And then when we add these together, we get a total area of 62.1 square millimeters. Okay. Now those were two pretty straightforward composite shapes. So there's really only one way to cut them into those component shapes. But let's take a look at this figure right here. Now I have multiple copies of it because I want to show that there's actually many ways that we can find the area of this figure, and some of them are a lot easier than others. So just to give you an idea of all the different ways you could do a composite shape, but then think about what maybe would be the easiest way to do this, because there are some complex ways that we can get the answer here. So I don't know how you visualize this, but there are many ways that we can break this up. One way we can break it up is to kind of cut it right here. Was that you? Were you thinking that? So we kind of cut the top off and we create this rectangle here, and then that leaves another rectangle down below. So then that would give us an area in the red region of 3 times 2, or base times height, or length times width, however you want to think of that. And that's an area of 6 square feet. And then inside this longer rectangle, that would be 10 times 3, which is 30, which gives us a total of 30 plus 6, or 36 square feet. Now that was a pretty painless and straightforward way to do that. We might see that that's the easiest way to do this. However, maybe you were thinking, no, I wanted to cut it this way. I wanted to cut that rectangle off the end. Maybe that was you. And then you have another rectangle here that we can find the area of separately. Well, here we're going to have to do a little bit more work because we have the length or the base of this rectangle, but we don't know the height right off the bat. So we have to kind of add these two lengths together, this 2 feet and 3 feet, to give us 5 feet for the height of this one. So 5 times 3 would give me an area of 15 inside the blue rectangle. And then be careful, because a lot of people would be tempted to do 10 times 3 again for this one, but this is actually isn't 10. This is 10 less 3. So this is actually 7 feet, 7 by 3. So this gives me an area of 21 square feet inside the red rectangle, for a total area of 5 plus 21, or sorry, 15 plus 21, which is 36 square feet. Notice we get this exact same area. Now, one was slightly easier to do than the other, so maybe one of those, you fell into one of those categories, and I would probably say the one on the left was a little easier. Let's look at two even other ways that we can do this. Now, some people really have thought of this like this. Now, I never think of it like this, but I guess you could. Here's a trapezoid. If you kind of slice this diagonally, you get a trapezoid, and then what's left is another trapezoid. So you actually can create two trapezoids with this figure. Trapezoid usually isn't the first thing that comes to mind, but let's see if that works. Now again, we already know that this is 5 feet here, and the area of a trapezoid is 1/2 of base 1 plus base 2, and then these two parallel sides are the bases, so that would be 2 plus 5, times the height, which would actually be the 3 feet there, which gives us 10.5 square feet for the red trapezoid. And then for the blue trapezoid, this is 7, we figured. And again, that's 1/2 base 1 plus base 2 times height, which is 25.5 square feet. And then when we add these two together, you get 36 square feet. Now you're probably thinking, wow, that was a lot of work and way more complex than either one of these two. And I would totally agree with you, but you can see that it works. Okay, so if you visualize it that way, and if that makes sense to you, you're going to come up with the same answer. Now, another way to do it is to kind of think of the negative space that we would call that in art, the space that isn't there. So some people think of this kind of as one large rectangle. They'll kind of complete the rectangle. So think of this big red rectangle here, and then we're going to remove or subtract the area of the negative space here, this blank space in blue. Now the large rectangle is 10 by 5 or 50 square feet. And then we're going to subtract the area of the blue, which is 2 by 7 or 14 square feet. So 50 minus 14 is, you guessed it, 36 square feet. So you can get the correct area many, many different ways when it comes to composite shapes. So really, however you see it or whatever makes sense to you, obviously that's going to work. But just be careful with your measurements and make sure you find the correct measurements if you have to figure them out if they're not given to you.